टेबल छोटी स्कूल में ये वो छोटी सी ऐसे कैसे मैं खा लूंगा ये बाद में खा लूंगा कोई मसला नहीं है.
Oh, I guess better. So it's a basic IT training course for you guys to start a new career. But as some of you are from non-IT background, your degrees are different and your experiences are different. So considering this, day 1 and day 2, we will be discussing some basic networking, IPs, classes, IP subnets, gateways, DNS, firewall. Not that much firewall, but at least we should know what firewall is, so that we can talk to our VMs, we can communicate with our VMs and stuff like that. So before jumping into the systems directly, I was thinking to touch some thing from network side also. And then we will jump. Okay. Then we will jump into Linux. We will install Linux. We will discuss Linux. We will discuss some commands. We will implement some commands, and we all will install the Linux. I will go with the Centos 7.9. That is very basic, very easy, and the most widely used operating system in Unix family. And we will see how we will log in. We will discuss the command lines. We will use them, and so much stuff in Linux. Till day 10, we will be discussing just Linux. No, yeah, day 11. Then we will install some packages. We will create our web servers, and we will discuss some error codes if we want to manage. We will discuss what is Apache, which is actually a web server, what is PHP, what is MySQL, what are databases, and stuff like that. The module 2 is automation of the systems. First, we will deploy our virtual machine, and we will manage it manually. And then we will deploy an automation tool, Ansible, and we will discuss why we will use Ansible and how we will use Ansible. And then Ansible works through YAML language. So we will be doing some YAML stuff. We will be writing some stuff, and we will be discussing some very simple YAML examples and then YAML projects. We will do Puppet. We will discuss Git. Maybe you have heard of a Git. Git is a repository from which we can upload and download the code, but we will discuss it later. We will discuss cloud, infrastructure as a service, platform as a service, software as a service. We will discuss some Azure here as a cloud. We will discuss what is virtualization, what is virtual machine. And then even I am a bit tense here because, after doing all that, we will discuss Dockers and containers. Maybe you have heard the services, the name microservices. We will discuss Dockers here. We will deploy Dockers here. And then we will go to the Kubernetes, which is way ahead of Dockers, how to manage a cluster, how to manage your Docker containers. Then Windows System Monitoring, day 23, Active Directory, jump host, remote desktop, troubleshooting, patching, upgrade. In monitoring, we will discuss how to monitor a system, and we will discuss some tools, Splunk, Grafana, and ELK. And then we will be doing some troubleshooting, how to sort your log files, how to check for errors and permissions, firewalls, SC Linux, service, if service is running or not running, why it's not running, network issues, latency issues, database troubleshooting, and then help desk, ticketing system, PKI, SSL certificates. And I think it's too much for you guys, but let's hope we do it slowly, gradually, and we move towards our goal. So this is the course outline. If you have no background noise, you can unmute your mics, and so that we can discuss it and we can make this session interactive.
Sounds good.
I have one question, Zishan.
Yeah.
How long this training will be? It will be for 4 weeks or for 8 weeks?
It will be for 6 weeks.
So gradually you will be going from Linux to cloud to DevOps.
Automation, not DevOps. Actually, I am hearing my own voice. If you can.
Is my voice audible now?
Your voice is audible. But I am listening my own voice.
I don't know. I don't know why it is getting a call. Just a month.
Maybe you are on speaker.
No, I'm not. Let me type so that you will not have
Okay,
any
I can
problem.
listen.
I can listen
And you can
speak.
Nothing more. So I was asking that it will be of 6 weeks. That's all. So you will be going firstly through Linux and DevOps and cloud and automation. Is that right?
Yes, central containerization.
Okay.
And by the way, it's a huge course because we don't. I don't want. It's like I want to do it everything practically, and you will be doing it all along with me. And if you don't do it, then you will not get it. So what I will do in the class, in the 2-3 days, you will follow me and I will tell you how to install Linux and you will be installing it with me. I will tell you how to access your VM and you will be doing it. So in the start, we will be going very slow so that you all come to the point that we can like move ahead easily. So first of all, any questions with the course?
This is Jay. I have a quick question. Is there a prerequisite list for before the installation? What kind of systems that we need? What kind of configuration that we need? Or will all be there in VM?
Okay, everybody needs VMware Workstation. You should have a basic Linux ISO, and you will install it. I will give you, if you have already, doesn't matter you have iOS, Mac or Windows. Package is available for both. I will give you the operating system, and you should have at least 8 gigs of RAM available at least. And CPU, I don't mind, because we will be running a single VM, and we will be doing everything on that VM. Maybe in the future 2 or 3 VMs, but 8 gigs is enough. And I suppose this should not be a problem for anyone, right?
Not for me.
So if anyone has problem, you can tell me right now. So I suppose everybody is good. Let me do one thing. I can upload it to, okay, I'll do it later after the class. So we will be needing a VMware Workstation. We will need an ISO, and for now, that's it. We don't need anything else. So anybody has any idea about IP classes, IPs, subnets?
Before we go to the VMware Workstation, should we install that from online, or would you be providing us?
I will be providing you the software. If you have it, it's good. If you don't have it, I will share a link. You can download it from there, and after the class, you can download it and you can install it before the day 3. So now, to make it interactive, any idea what's an IP address?
So it's basically to communicate with other systems, one systems to another system. It's like to make them talk to each other.
Yes. And what is internet? Hello, just make a wild guess. What's internet?
Collection of different networks.
Yes. And we type www.yahoo.com, google.com. So it's a world wide web. We are connected through IP addresses with the whole world. Every PC, you are now connected to an IP address. I am connected to an IP address. And the packets are flowing, our voice is going here and there, and it all goes through by using these IP addresses. And we will discuss, you go to google.com. Google is a web server. Google is hosting some web server. The web server is running on some machine. The machine is assigned again an IP address. Okay. When we type google.com, my machine. So you anybody knows what's a DNS server?
It's basically converts your IP to domain name,
and domain name to IP address.
Yeah, correct.
Both way, IP to domain and domain to IP, because there are like million and billions of IP addresses. If I want to go to google.com, if there is no DNS server or there is no DNS service, I should remember the IP address of Google. I should remember the IP address of Yahoo, Hotmail, ChatGPT, whatever. So it is very difficult to remember the IP address of each and every service. So there comes your DNS. DNS, what is DNS? It converts your IP address to a domain name, which is easy to remember, like google.com. And if we type google.com, it translates back to the IP address where google.com is hosted. So let's go on the board, and I will discuss it on the boards just to make it more interactive. I'm going to stop the share. It's our day one. So I was telling you, and you have some background of telecom, some guys have background of system, but we have people from finance and MBA. So if they don't understand or don't get it, please tell me so that I can repeat it. Okay. So
Yeah.
what is an IP address? X.X.X.X. We are discussing IPv version 4 because it is still the most widely used IP scheme in the world. The IPv6 is there, but still everybody is comfortable with IPv4. And why we are going to IPv6? Because the IPv4 addresses are exhausted now. Today, everything is connected to IP. It is the age of Internet of Things. My air conditioner, it is connected with IP. Our mobile phones, our washing machines, microwaves. So everything is connected to an IP address because so that you can control it from anywhere. So these addresses, actually, they are now exhausted. So we have gone to IPv6. So IP address looks like anything. There are two types of IP addresses: the public IP addresses and the private IP addresses. So it starts with 0, 0, 0, 0, 2, 255, 255, 255.255. These are actually 8 bits number. And there is a problem that the finance people, they don't know what are the bits, right?
Yeah.
Okay. So let's assume the system works with binaries like zeros and ones. Everything is either 0 or everything is 1. And then we can represent, actually everything works in ones and zeros, and then we can convert them in tens and hexadecimal and decimal. So with this number, with 8 bits, I mean, this is your 1, 2, 3, 4, 5, 6, 7, 8 bits. If this bit is 0, all bits are 0, the number is 0, you will get 0. If this is 1, you will get 1. If this is 1, everyone has done mathematics. What is 2 power 0? What is 2 power 1? If this bit is 1, this bit is 1, then it is 2 power 2, it is 2 power 3, like that. So 2 power 3 is 8, 2 power 2 is 4, 2, 0. And we can add up this number and we can represent it in decimals, like 14. The representation of 14 in decimal, in binary, in digits, zeros and ones, it can be represented as 14 or 1111 in binary system. So I will not explain it a lot. You'll get confused. You just should remember the range grows from 0 to 255 for all these octets. These are called octets because these are 8 bits. And the IP address looks like, let's say the private IP address 192.168, maybe 1.1. So if you can 192.168.1.1. So it looks like an IP address. This is the first octet, this is the second octet, the third octet, and the fourth octet. In your computers, you are assigned an IP address. I think the camera is disturbed, sorry. Yeah. If you go into your Wi-Fi settings, you can check what IP address is assigned to you. Anyone can tell me their IP address. Just check it and tell me. Hello? Anyone? Okay, I think I should do it.
I can go ahead if you want. It's 192.168.0.19.
0.19. Perfect. And how you can check it?
I actually did it through command prompt.
You did it through command prompt. That's the better way. But can you see my screen?
Yes, I can see.
So I have gone to my network settings, and this is my connection, the wireless connection, and these are the properties. So I have used DNS 8.8.8.8. I did it manually. I'm not taking it from the DHCP, but the IP assignment is DHCP. And my IP address is 192.168.100.49. And DNS, I already told you, it's 8.8.8.8. So my machine is assigned a private IP address, but if I go on, what is my IP.com? Okay, my public IP is 39.32.46.230. So my private IP address is of 192.168 series, and the public IP address is a public IP address. And what's a public IP address and what's a private IP address? We can discuss it. Just let me write down my IP address on the board, 39.32. And 46.230. And the private IP address is 192.168 and 100.49. So this is my private IP address, and this is a public IP. This is private IP. So the public IP address is out of my control. My service provider provides me this IP address through some system. Okay, just I can stop the share. Yep. So 39.32.46.230 is the public IP address provided by my service provider to the device which they have installed at my home. And this is single IP address. If I go on my laptop and go on to what is my IP.com, if I go to my mobile, my tablet, my other PCs, my TV, everywhere, this will be the public IP address, and the private IP address, they will all be different, because in the same network segment, which is my home, or every device, every client device connected to my Wi-Fi device. So this makes a small network. So they all will have the same IP series 192.168.100. The last octet will be different. It will be 50, 51, 52, 53. And this is assigned by my router to all the devices using another thing, which is called DHCP server. It's a dynamic host control protocol.
We can't see your.
You cannot see the screen?
Like
I can.
you're writing.
It's visible for me.
I told you just to pin it so that it will get maximized and no other video comes over it. Are you good now?
Yeah.
Yeah, just pin it. So I was telling you, I have a public IP address 39.32.46.230, then I have a private IP address. And these private IP addresses are controlled by the DHCP service, which is installed in that small device, the CPE, the customer premises equipment, or the device installed by your service provider at your home, from which maybe you all are connected. If you are connected through a mobile network, so your mobile network then assigns a, I mean, in mobile network, it's different. I'm not from telecom side, so I should not jump into it, but they should assign some IP address, maybe public or private, to your client device, and you're connected to internet. But it is all the same. The world is connected through these IP addresses. So there are classes of IP addresses, class A, B, C, D, E, F, maybe. I'm not the, I've done my network stuff very earlier. So we just should remember that 192.168.x.x, when these two octets are in the start, it's a private IP address. It could be 192.168.0.1. till 255.x, 0 from 0 to 255. So, but we will see the first two octets only. This is our private IP address. We cannot use it publicly. No website can be hosted on these two IP addresses. Then there is a very huge class 10.0.0.0. So if we see 10 at the start in the first octet, it's a private IP address. You can use it for your office, your LAN. I mean, what's the LAN? We will discuss it. LAN is your local area network. So local area networks can be huge. Thousands of PCs can be in a local area network. Like in our offices, we have thousands of PCs, and they are all connected to mostly 10 dot network. So this should be X, X, X. So starting from 10 dot, it's a private IP address. Then we have 172.16.x.x. So these three, out of those 4 billion IP addresses, these three subnets are, they are free for us. We can use it. We cannot use it publicly, but we can use it privately. Any question till here?
And these classes are same irrespective of the country, right?
Yes, it is the same globally.
Okay.
Because the IP address is global. I can ping you, you can ping me. So it's global. So I mean, only you are interacting with me. Nobody else. I think that they are getting it all, or they are not getting anything at all.
No, we're understanding.
Okay, good. So then what is this? My public IP address. This is a public IP address assigned to my device. And this is the private IP address assigned to my PC. So what's happening here? There's a concept of netting. Any idea about netting? Network address translation?
No.
Nobody? No.
Nope. Unfortunately.
So,
is it similar to masking?
No, not masking. It's literally translating.
Okay.
So I actually don't want to go very deep, but I don't want to skim it. So I want to be in between. That's what I'm trying. Let's say you have an IP packet. Let's discuss it a bit later. Not now. You'll get confused. A bit later. Let's leave it.
So to make it a brief statement, so ISPs will take your private IP and literally translates in.
Not the ISPs. It's your device. It's your CPE. What it does is it maintains your sessions. You have an IP address. It will take your IP address, and while going to internet, it will replace that IP address, your machine's IP address, with the public IP address provided by the ISP. Because private IP addresses are not allowed to travel on internet. So it will replace your private IP address with the public IP address, go to the internet, go to the designated location, and when it comes back, it comes to your CPE. And your CPE knows from which IP this request was originated, and it will convert back to that IP address and send the data to that machine who has requested the data. Let's think it like that. I mean, it is like that, but I will explain it later how it's done.
Okay, so one last question, if okay. Yeah, say suppose if I have two devices connected in my network with two different IP addresses.
Yes.
When the conversion happens, will that be only one public IP address or two public IP addresses?
One public IP address for all your devices connected to your CPE.
Okay.
You understand?
So any traffic that goes from my router will only have one public IP address.
Yes.
No matter what device it is. It could be 192.168.1.1 or 1.52. It doesn't matter.
Doesn't matter at all.
Okay. Got it.
You have 100 devices at home. They all will use that same public IP address. And nowadays, there is another concept that your device will be assigned a public IP, private IP address. What will happen? You are assigned 192.168.1.1. Your public IP address is actually private IP address 10.10.10.10. And your service provider, he will have 202.83.164.10. Okay, from your house to your CPE to your service provider, it's a private network. It will be either connected with fiber, or it is connected with, I mean, in old days, it can be coaxial, it can be dial-up, it can be DSL or whatever. So what ISPs these days are doing, these all IP addresses, .2, .3, .4, .5, the traditional way was to give a public IP address here. Now they are giving this, they have taken this public IP from this place to their own devices. And now what they are doing is they are serving another customer 10.10.10.20 or 30. And again, they have complete network over here, and they are doing translation 2 times. one translation from here to here, another translation from here to here. The same concept we were using here, now ISPs are using it to serve more customers with one IP address. Why this concept came? Because the IPs were like, if we go 5-6 years back, IPv6 was there, but all the devices were not supporting IP version 6 protocol, and the IPs were decreasing so much that they had to come up with this plan. So this all is done through network address translation, and the system do it very efficiently. And are you getting it? Especially for you, Jay.
Yes.
So how it is done? What's network
Yeah,
translation? We will discuss it later.
Yeah.
Sorry. Yeah.
Quick question on this: will there be any latency in traffic by changing?
No. No.
Okay.
Less than millisecond. I mean, it's on wire speed. We call it wire speed. There's no latency.
Okay. And
anyways,
backtrack to the device. How do you backtrack to the device? Like,
we don't do it. The device does it.
Okay.
So it's all very established. So how it is done, I can explain you, but it's done by the device. We don't need to. Okay, but we should know, because we are actually this course was designed to get you. You can change your field from some other IT to system administration. Maybe you are a developer and you don't want to continue as developer and you want to switch to systems. You want to go to Linux administration, or you are some finance or accounting or from any other field, and you want to switch to systems. This course is designed by keeping that in mind. But you know, the course is so huge that I don't agree with this course, by the way. But I will try my best. So we were discussing Google.
Appreciate your patience with us on this.
Okay, Google.com. So whenever we type Google.com in our browser, the web page is there for you. How it is done? I told you, I have used. This is done through DNS, domain name system. If you go to our browser, we type Google.com. Our browser goes to our local cache. What's a cache? If any activity is done recently, it stores it in a temporary memory that's called a cache. So it says to the local cache, a local DNS, hey, I want to go to google.com. What's the IP address, or what is the A record of google.com? What's the A record? The DNS serves many record types: A, TXT, CNAME, MX, TTR, and a lot more. So to browse a website, it always looks for the A record. What's the A record for google.com? It will reply you with some address if it has it in the local cache. If you don't have it in my local cache, it can go to one ahead. Mostly it's a forwarding DNS. If it has no IP address, it will forward to your request to another forwarding DNS. Until if none of it has that address, then it will go to the root servers, root DNS servers. We will discuss root a bit later, but eventually, if this address exists, if this domain is registered somewhere, and if it is assigned an IP address, eventually your DNS will search for it, and it will all be done. I mean, every first time, maybe if a website pops up in the world somewhere and nobody has ever looked for it, so it will not be available in the cache. But if once someone accesses it, every DNS server will cache it, and that this whole procedure is done in just a millisecond. I mean, it's very fast. Everything is done in milliseconds. The internet speeds are very high. The latencies have dropped a lot. So how to look for a DNS address? I'm going to my machine and I'm sharing my screen. So can you see the command prompt?
Yes.
Okay. There is a command ns lookup. So default server is DNS server of Google. The IP address is 8.8.8.8. I have assigned it manually because I don't trust my ISP's DNS server. So I directly go to Google DNS server, and this works fine for me. Let's say I want to know the IP address of google.com. So google.com has 2 IP addresses. This is an IPv6 address, which I was telling you that I'm not comfortable with. So, and this is a IPv4 address, 142.250.181.78. When I go to my browser and type google.com, the google.com IP address is this. And my browser goes to this IP address to download the content. If I go to yahoo.com, okay, Yahoo has so many IP addresses. And this IP address, if you think there is one server behind it, no. There may be thousands of servers behind this IP address, because there is so much load on this, on maybe Yahoo, that millions of people are accessing yahoo.com. So there is no way that this IP belongs to one server. What I believe is this IP address is of a load balancer, and behind that load balancer there can be thousands of systems running serving the Yahoo content. Then maybe your company website, if anybody works in some company, you can tell me the domain name and we can check it. Amazon, AMAZA, Amazon.com. So this is Amazon.com. So these are all the IP addresses of Amazon.com, and maybe they must be running a lot of servers behind it. And these are the IP addresses of a load balancer. What is a load balancer? Load balancer is like you have 10 machines. Let's discuss load balancer here. I can go on the screen.
Before we go there, when you say IP addresses, those are public IP addresses, right?
Those are all public IP addresses. Yes,
okay.
They don't start from either 192.168. They don't start from 10.x. They don't start from 172.16. So these are all public IP addresses. And I don't want to confuse you, but if you say that, I don't know the Windows command, I don't remember. I think it's QUARY AMAZA Amazon. If I do it like that. I am kind of more of a Linux guy, so I hate Windows. That query is equal to MX. Yep. So I told you we have A records, we have text records, we have MX. What's a MX? MX is your mail exchanger. What's a mail exchanger? You have, what is a mail exchanger? It's your mail server. Amazon-smtp.amazon.com. If somebody is sending email to amazon.com, your Google tells that email server, your email server, like if I am going from Gmail or my office email server, that I am sending email to Amazon. So my email server or my mail exchanger goes to the DNS and asks for Amazon mail exchanger. And this is amazon.smtp.com. Okay, so now amazon-smtp.amazon.com. So this is all the details related to, and if I set query is equal to A again, and this is your Amazon SMTP amazon.com, which is a mail exchanger, and the IP address of that mail exchanger is this. So everything, my mail server first look for the mail exchanger through MX records, and with again, that's actually a domain, and that domain is pointed on again some IP address. So then the IP address A record is found, and it will deliver the mail to Amazon by using SMTP, which is Simple Mail Transfer Protocol. Any confusion till here, other than J? It's not Linux. It's just basic routine stuff before going, because we will be needing all these concepts in future classes. So everybody should understand this. And if somebody is having any problem, please let me know. So should I assume that everybody's getting it?
Yes.
Okay, that's good. That's nice. So that's how important the DNS service is. If DNS is gone, I mean the whole internet is gone. Nothing is there. Nobody remembers the IP address of whatever.com. And there is one important thing. There is a configuration file, etc in Linux. Okay, don't discuss the path. It's the host file in Windows. I can share my screen. Let's just share another screen. Let's see. Okay, not bad. Can you see the notepad?
Yes.
Yeah.
If I can press open, can you see which file I am browsing or not?
Yeah.
Can you see this host file?
Yes, we can.
Okay, that's good. So if I can open it, so I can show you. I don't know, I shouldn't have shown it to you. Let's say this is enough. Here are a lot of stuff written there. So this is zdashboard.com. This dashboard is not publicly available. Maybe phpmyadmin.com is available, but it looks like a legitimate domain. But definitely zdashboard, actually it's mydashboard.com. This is running on some machine having some private IP address, 192.168 series. I can look at it, it's 192.168. And I don't have a DNS record. So what I can do is this etc host file, I put an entry in this, like this, first the IP address, few spaces, and the website name. I can type it anything because it is my computer, it is locally resolving. It's not going to DNS server, it's not going anywhere. So if for testing, I am running some web server on my local machine, and I want to check it if I go through a domain name. This is a domain name. This is called a domain name. Google.com is a domain name. Yahoo.com, it's a domain name. So if I want to test it, if I browse it through a domain name, how it will behave. I'm a developer. So if I do, I give a IP address and a domain name here. In the path is for every system in Windows, it's C, Windows, System32, drivers, etc, and the host file. In Linux, the path is different, but again, the same host file. And if you type something in your host file, let's say if I type google.com with wrong IP address here, my browser will only look for this IP address. It will not go for DNS and check for the original Google IP address. So sometimes we do it for testing, and if we forget, maybe it can create a problem for us. So if any domain name entry is here in our etc host file, my browser will not look up for that domain in the DNS, and it will trust that if I am writing this, I am the system administrator, it must be right. That's why this file can only be opened through administrative user rights. With normal users, you cannot edit it. Even you have to open the notepad with administrative rights. Otherwise, you cannot edit this file. Am I good till here? Yes. So, okay, everybody's getting it. So I was telling you, I don't know why I came here. When we were discussing DNS servers, I can stop the share. And yes, we were discussing on DNS. So we were here. So if we want to host a website, we can edit our etc, or we can edit our host file, and we can force the browsing to that file. So we're all good with that. I'm going to the board again. One more thing. How this translation was done, it is called, there are two terminologies, D, NAT, S, NAT. DNAT is destination NAT, SNAT is source NAT. Destination, and this is whatever, source NAT. Since start of the class, we were saying we have 192.168 assigned by our CPE or our device, Wi-Fi device. Through DHCP, we are assigned some IP addresses 192, mostly 192.168 series, because it is it's more than enough for a small network which is connected to that device. So this is source NAT. Your device is doing the source NAT, which means it is taking the source IP address 192.168.0.12345 and translating it with one public IP address. So many to one. So many devices are coming to your CPE, and it is converting it to one IP address for browsing the internet. Destination NAT. One too many. It's opposite. let's say I have a public website. We were discussing it. It's a google.com. Let's say the IP address is 54.100.10.20. I have a web server, which is doing google.com, serving the content. This is another server. This is another server. And maybe I have thousands of servers. And this is 192.168.1.1. This is .2. This is .3. This is .4. So I was telling you, this can be load balancer. And all the traffic is coming to this IP address. And through load balancer, we can load balance between a lot of servers. And there can be many mechanisms. We can use this DNAT. Actually, while DNAT, we can use port translation. Okay, first, why I'm telling you port translation. You have any idea about the ports? What's the port? Anyone? What is a port? Any guess? So let's forget all. So google.com. We were discussing the IP addresses. I think you guys should you should do some self-study also. The services like DNS is a service. There can be a web service. SSH is some service. SMTP, we were discussing it. Simple mail transfer protocol. Maybe some of you have used Outlook for your emails. So that use POP 3 version 3. DNS listens on port number 53. Any website, google.com, listens on 2 ports, 80 and 443. This is encrypted, this is non-encrypted. Port 80 is non-encrypted. If you type in your browser in the older days, http yahoo.com, the request goes to port 80, traffic is unencrypted. If we type https yahoo.com, the traffic is encrypted. But nowadays, if you type http yahoo.com and hit Yahoo server, it will automatically redirect your traffic to HTTPS because the security is much needed in this era. So even if it listens on port 80, it listens just to redirect. Otherwise, if this port is not open, you will hit that port. If that port is not available, nothing will happen. You'll be stuck there. Then there is the service called Secure Shell, port 22. SMTP, we deliver mails on port 25. POP3, we pull the emails from our email server through port 110, and so on. So many services. So everything run on some port numbers. This port number is, I don't know how to define a port number. It's like your IP address, 192.168.10.10, your port number. This is your port number. The IP address has an additional attribute. The IP packet has an attribute that, okay, network is layer 3 traffic. It will just give you the reachability, the packet from place A to place B. But the ports are at layer 7. So you should go and study what are the OSI layers. Because, I was assuming a little bit knowledge. Because we used to get it, if you are doing the engineering, you are doing the BS. So we do all this stuff there. But maybe in the other fields, or of course in the other fields, you don't get these networking stuff. So you should learn a bit about this OSI model. There are the network is divided in many layers, like 7 layers. You have physical network layer, your cables are connected through physical, then you have data link, then you have network, and so on. And on the top, you have the application layer. So the network packet is well constructed. It has all the information that service is running on what port. The traffic is TCP or UDP. TCP, all the communication, the websites in which the delay is not important. If your website opens 1 second later or 2 seconds later, it doesn't matter. But if I am talking to you, if my voice is delayed, you will be in pain. I don't want to go in that detail. So I'm talking to you in a UDP protocol, and the websites are working on TCP protocol. So just leave it, just forget it. I don't want to go into detail. I don't want to go a lot today. So I'm open for questions. That's it for today.